Hey guys, how's it going? Got to clear up my throat a little bit. It's always weird when I come back to stream after not talking for like a whole week. But how's it going, BlazeX and Marky Pews? I hope you guys are doing okay. So in this stream, what I want to get done is basically like we have first person controller and everything. I want to start getting like actual chunk generation done and hopefully texture mapping so we can get like different blocks into the world and stuff. And we also need to cull faces. So those will be the three big things that I'm going to be doing today. In the last stream, we got to almost a chunk. And then in my off time, I sort of did some debugging and then got it so that we actually have a chunk generating now. So we actually have a bunch of grass cubes just going all the way up. But there's a big problem, which is if you go inside of it, you can see that we have all these extra faces, which is bad. And we can solve one of those problems pretty easily, just literally by saying GL enable GL cull face. And this should cull the back faces. So if I set everything up correctly, we should just... Okay, yep, so we almost get the same thing. It looks like I have to change up the way we're doing the bottom face because that's not working correctly. But if we go into the inside, you can see we don't get any of the weird glitches. And then if we try and look out, you can see that the face has now disappeared. So that's one really easy optimization that you can make if you ever have to. But let's go ahead and fix those bottom faces first of all. Oh, and hey Voxel Rifts, how's it going? Okay, so to fix the bottom faces, I think we basically just set it up inside the chunk where we have each face. Yeah, so I can just go into here. What's probably happening is I'm just doing these counterclockwise instead of clockwise, which is why it would be culling it the wrong direction. So I say to do this by going 4, 5, 6, 7, which doesn't seem to be working very good. That's probably because of the elements, which are set up right here. Okay. So instead of going 4, 5, 6, 7, I'll probably just try and go the other way, 7, 6, 5, 4. And hopefully that'll make it just so that we have those going in clockwise direction now. Yep. Okay, cool. So that's just like something with GL. If you have them going in the wrong direction, it just doesn't work out very good. So, but now if we look down, the bottom face is cold. I'm going to check the top face too, because I have a feeling I messed something up there. And that's kind of weird too. My player controller doesn't like going to the right at certain angles. Like it's super slow. So I'll have to look into that too. But change the winding order. Yeah, so that's basically what I was doing by just changing the order of the vertices. Because I feel like if we just keep the elements in the same order of the index, that's a little bit easier, but yeah. Okay, cool. So the top face is good too, and we're good. But like I said before, that's only one problem, because if you look inside, we still have the problem of all these extra faces being drawn. So if you're rendering all those extra faces for no reason, then it's going to be a big tax on your GPU. Right now, it's not that bad because it's just one chunk. But once we start getting to multiple chunks and everything, it can really start affecting performance. So I'm going to save that for a little bit later. But first, what I'm going to work on is the texture mapping. The way I've been thinking about doing the texture mapping too is basically... Oh, and I guess I should talk about how I debugged that problem too. So the way I debugged the problem is there was a problem inside of the chunk generation. I was just basically expanding the thing wrong. So... to figure that out, I just sort of listed out the important numbers for this equation. And then I realized that I was messing up the equation, and I fixed the equation by changing this, and then it all worked out. So just in case you were wondering how that happened. But yeah, anyways, how I'm thinking of doing the texture mapping. So basically I want to have this thing, which is like a block map. And for each block, I want to have a file. And so for like, say, grass block, the file would look something like that. We would have like probably block, and I want to do this in YAML because apparently Cherno says YAML is easier. So we're going to do YAML format, which is just that. But anyways, we'll go in 2 indents or whatever it is. And then for this block, we'll have like ID, which is 0. Actually, we'll do 1. We'll save 0 ID for like the null block or something. So 1 would be like grass block. And then we would have like UVs. And those would be like UV1, 0, 0. I'm not sure how YAML works, so we're gonna have to look into that format and everything too. I think it might be like UV1 and then it would be like X and then it would be like Y. So probably more like that. But basically you get the idea. We just sort of go on, we list all the UVs, and so that's for a grass block. And then we basically load all this into memory on the game start so that we have a way to figure out what texture coordinates to use and all that stuff. And we'll dynamically patch it at runtime too. So like in addition to having the UVs, we'll also have like texture. And then this will be like grass block side.png. And this will be like right side. And then we'll have like left side. And then so on. I'm not sure if this is the greatest idea. I mean, we could probably just do for now side and top and then bottom, which will definitely work. The only problem I think is going to happen when we have custom blocks. So those don't just have 4 sides or 6 faces. Those have a lot more. And hey, BlazeX, how's it going? And Emogi, how's it going? And you didn't miss much. I'm just sort of talking about what I plan on doing for this episode. Okay. So, yeah, I'm not sure if this is going to be the best format to store these because when you get more custom blocks and stuff, you clearly need a different way than just doing something like this. Maybe a better way would actually be to do something like we have the UVs and then we also have like vertices. And then the vertices basically just sort of defines the way you actually draw the object. And so I can just load the vertices directly from here and then the UVs map to each vertex. So that could work, but then, okay. Then we're getting into like, that's basically just an FBX format or something. So why do that when I could just do like grass block ID, and then I could say like block format, some file.obj or .fbx or whatever. And then inside of this FBX file, which I guess this would technically be like grass block, that has all the vertices, and that also has like the textures, the texture coordinates, all that stuff too. But we run into other problems there too. So yeah, for now, I think it's just gonna be easiest if we stick to this format where it's just like side is grass side.png, and we'll say top is grass top, and then we'll say bottom is dirt.png, and then we'll just say UVs and list the UVs there. Okay, so that should work out. And I don't even know if we need the UVs actually per block because we could just get the UVs from the pictures too. And so then in addition to having this block format file, so this will be like a block formats.yaml. We could also have like another file. So that would be like all the block formats. And then the other file would be like textures.yaml. And then this would just be like texture ID, which we'll just have it incrementing the same way, just starting from 1. And then it would just be like name is grass side.png. And then UVs would be whatever. So I think this is probably the best way to do that. 2 separate files, and then we can just map from here to here. And then we'll just sort of get it all combined inside of the block map inside of RAM when the game loads, so that everything is sort of dynamically patched up and stuff. And then we can just add new blocks and stuff by adding to the YAML. Yeah, I think I like this idea. And BlazeX says, just make a flat place of grass blocks first and then add Perlin noise. Yes, I want to get to that, but I think this is important because once we get this done, we can very easily add in new blocks and stuff and sort of get that working. And if the grass is facing air blocks, draw the face that is facing to there. Yes, we will get to that too. So that's like the culling that I was talking about, where basically we'll have to create an algorithm that looks to see which faces are actually like facing other faces. So like this is the inside of the block and these 2 faces should not be showing. So we'll have to like create something like that. And you'll also have to have it figure out like, oh, should I draw this face on the outside if it's next to another chunk and that stuff. I just realized too that my mouse capture's off. So let me turn that on real quickly. Okay. But yep. So for the internal format for this thing, how are we going to represent all this stuff? Well, we could do an array or we could do a hash map. I think if we're going to do IDs as just numbers, we could just do an array, and then we could have a hash map that maps from an actual name to an ID. And that will be sort of a good in-between spot. So yeah, so I'm going to say we'll have like a hash map that goes from, I have something called a C string, or actually I think I just called it a string now. Oh, that's a good idea too. I should actually pull my changes from CPP utils because I've made some changes in there. So this is sort of my custom library that I made that just has a bunch of data structures and stuff. So I will just go ahead and say pull so that we have, okay, I already have that up to date. Cool. So let me just make sure I have that actually up to date because there's a chance that I didn't push anything to it too. So let me just go into here. And I'll say that. Okay, yeah, so this is not up to date. I should probably make this up to date because it has a lot of changes. Okay, cool. Well, I guess you guys can sort of get a peek into this library too. This is basically just a data structures library. It's got like strings and all that stuff and then a bunch of tests. So I'm going to run the test real quick just to make sure I don't have any broken stuff right now. Okay, so that's good. And then just run that too. And that is not good. Okay, cool. So I just got to update the single include. So the way I update my single include is very laborious. It's not the best way to do this, but I really don't care because I only do this every so often. Okay, so I just go into here and then copy and paste it into here. So I'm going to do that. Here, let me delete all this too real quickly. Delete that. Well, not delete, but just close those out. And yeah, I'm not going to hire Notch. I'm not that rich. And BlazeX. Okay, yeah, you asked if chunks work already too, and they sort of work. So sorry, I was just looking up in the chat a little bit. But okay, so going to copy this here. Yeah, this is memory. Okay, no, this is, okay, here we go. So I'm going to copy all of this over here. Cool. And then this one. Oh, okay. I see what I'm doing here. Normally I'm a lot faster at this, but this is early in the morning, so I'm still kind of waking up. Okay. And then I just got to copy the logger. What I'm doing here too is I just have a single include that I create, which is just easier to use in other libraries and stuff. So I just sort of paste everything into one big file that has everything, and it just makes my life a little bit easier. Okay, so I'll copy that. And this is like a completely separate library too from the Minecraft game that I'm working on. It's just something that I'm kind of using. Okay, and then delete that stuff. And BlazeX, you asked, it's a full cube. Is it supposed to be a square? Not sure what you're saying there. Okay, so this one is string. So just get that. Also, I'm not sure if I want to continue doing something like this. So basically I created just my own library with data structures and stuff, which I think is fun. And I've just sort of been working on it in my spare time. But not quite sure if I like it or not. Because lately I've been like, do I want to do everything myself or should I just use the standard library? Because the standard library works fine and there's no reason to re-implement everything yourself, really. So I'm sure if the real Kane was here, he would probably be telling me definitely not to do this because the standard library is perfectly fine. Okay, so that's the hash map. And I'll collapse that. And then this is the implementation file. So then I just have to paste in memory.cpp. Oh, and then I just closed out the thing that I need. Okay, so keep that open. And go back down to the implementation, which is right here. Okay, and then I'll paste all this stuff over too. I should really write a script to do this for me. It's just, it's kind of hard to write a script like this because you have things like that where it's, I have to remove certain includes and stuff. And I guess I could fix that just by having, okay, this is logger.cpp, having some special macros that automatically clean that stuff up. So I really shouldn't be doing this manually, but I'll fix it in the future one day. Okay, so then this is logger and replace that. And then we need, after that is string. So then I'll paste in string.cpp. And I'll paste it over this. And it should be almost done after this one. I think there's just, yeah, basically done after this. Okay, and then remove that. And I need hashmap.cpp too. Okay, so then I'll just paste that, take that away, and then run my tests, see if that works. And I'll try and not make the same mistake and generate crazy mountains like Minecraft initially did. Okay. So I just need to include a couple more things in here, which are some things that I added later on. So this needs string in memory. So I'll put this below string. Okay. So that's logger. And then that is list string hash map. Okay. So then I'll just put down here. And we'll remove that. And then we've got the implementation. So then I'll just get the implementation, copy that, and I'll paste it at the bottom because it shouldn't matter where you put implementation stuff. Okay. This is going to be there. And I think I need to stop it. Yeah, right there. Okay. Cool. So let's see if that works now. So should get successful tests. Hopefully. Nope. Okay, what's wrong now? It says path builder is already defined in hashmap.obj. I think I just need to regenerate my build system. See, this is some stuff that I probably should have done before I started the stream. I just completely forgot about it. Okay, so we're back in the single include. Run that. Nope, we're still getting errors. Okay, I'll probably fix this offline and stuff. And for now, I will just use the standard because that's going to be simpler. So we'll just have to include unordered map here. And then we can say stood unordered map. And this is going to be from a string. So I'll just use stood string to an ID. So I guess just an int. And so this is going to be like our name to ID map. And then we're also going to have a stood unordered map. This is going to map from. So we've got our ID map, and now we basically, this could just be an array actually. So we could just have a stood array. I'm not sure if I want this to be dynamic or not. So we'll make it a vector for now. Yeah, that probably sounds like a good idea. And what's the name of the clone? Maybe make a devlog video. Yeah, I might make a devlog video about it soon. I plan on, I think after this episode, we'll have it in a good enough state where I'll like actually make a video on my YouTube channel and just sort of be like, hey, there's streams if you want to come. But the name of the clone is just Minecraft clone for now. Like, I think, yeah, I just called it Minecraft. So I'm not clever with coming up with names, but if you guys have any good ideas, you should let me know and then we can change it. But anyways, this will just be a stood vector of block formats. And this will be our block formats. And we'll have a structure up here. which I'm going to call block format. And we basically want this to contain the useful information, which is sort of this stuff. Okay, so this would be like stood string, and using stood strings for all this is probably really bad. Like I should serialize this or like map it to some hash value or something, like a hash string, and then fix that all later and everything, which I will do, but for now we're just gonna do it simple. So change this to a string, and then this is gonna be the side, and then we also need the top, and we also need the bottom. So that's gonna be like the side texture, top texture, bottom texture. So that should be good. And I don't think we really have anything else for now. Yeah, that's all we're gonna have in here for now. And then we also need a structure, which is gonna be the texture format. And this is gonna have a string, which is its name. We'll call that texture name. And then this is gonna contain UVs. So we basically just want 4 UVs. So just 4 sets of vec2s, which we can say that's that UVs 4. Okay, cool. So that should be good. And I think I have GLM. Yeah, so we should be good there. Okay, so that should work out. And then we basically have this map. This is just name to IDs, and then this is just block formats. And we also need textures. So we also need a stood vector of texture formats. And all of this should hopefully work out. And actually, I'm going to change this. Instead of stood vector, we could change this to be like a map too. So string to a texture format. And that will just be the texture format. And we could actually just remove this too. And basically, this is our map. So there we go. Okay, cool. So like what I'm trying to do here is just sort of block out how I'm going to think about this conceptually. Because if we can figure out how to get a file mapping to an internal mapping and get those pretty efficient, then we should be in a pretty good place when we actually go to set everything up. So then I'm going to create like an interface of what I would expect, how I want this to work, which basically I want it to work where you can say block format. And I guess that'll be a const reference because that won't really change. Get block, which I think we'll do that way. Trying to see what my, nope, okay, I'm doing lowercase, what my style is. Okay, so let's say get block, and this will take in just a stood string name, and we'll take that by const reference because we're not going to be changing that. Okay. So basically, I want it to work like this. We basically say, I want to get this block, and then this will give me a block format, which will have the side texture, top texture, bottom texture, and the UVs, so that I know what to get for all the UVs. And then I want to be able to say void load block. And this will take in a const string ref, the name of the block, which is basically going to be the same name that we have in here, which I guess I should add. This is going to have a name, so that would be like grass block. So that way we can reference everything by names and stuff too. And voxel refs, you missed a lot, so what's happening? Okay, so I'll restart real quickly. We basically have right here, if this compiles, okay, no, I broke something. Yeah, I broke this. I basically set it up so that we have chunks working and everything. So if we go back in, nope, it's still breaking. Let's see what I got wrong. Okay, value type is not a member. Really doesn't like this. Okay, I'm just gonna comment all this out for now. There we go. Cool, now if I start this. Okay, there we go. So I got the chunks working and everything from the last stream. So I got that working, just one chunk for now. It doesn't actually do multiple chunks. And then I just enabled culling so that we get all the back faces culled. So if I go into the block, it's culling the back faces, which is good. That was just an OpenGL flag. And what I'm working on now is basically, I guess I should go back into here, is basically we have the grass side on the side, but then if we look at the bottom, it's still the grass side because I'm just using the same texture. and it's not really being mapped from anything. What we're doing is I'm just loading in one texture. Let's see. So yeah, I'm just loading in grass block side here. What I want to do is we have this texture packer, which packs all the textures into one big thing. I want to be able to use this, and instead of using one picture, just use the big picture and sort of get the map. And it doesn't really look like culling is working. It's weird. It is working. So that's another thing too that we have to sort of go into. And Essiewood says, do you have any suggestions where to start learning basic music theory? I have keyboard and enjoy playing, but some basic theory would be beneficial. I'll get to that in just a second. And voxel riffs for the interiors, the culling is working. The reason we're seeing these extra faces is just because we're building each cube individually. So we're not actually manually culling and anything. We're just sort of turning on backface culling, which is this flag right here. So if I turn this off, we can see, yeah, that if I go into there, you see that the faces are all sort of smushing against each other. And then if I look out, that we have all of these faces. And so the reason that we can still see faces inside when we turn culling on is because we're actually just drawing extra sides right now. And so I need to set up an algorithm which basically removes the interior faces and stuff, which is something we'll work on a little bit later in the stream. But Essiewood's for music theory, if you want to learn basic stuff, there's this website, musictheory.net. Yeah, this is super awesome. So definitely check that out. It's easy to remember too, and it helps teach you quite a bit. I think it's pretty good. So, okay, so back to what we were working on though. We were working on this. So now what I'm doing is I'm basically coming up with a file format. So this texture packer is going to write to that file format, preferably. So we basically are going to write out like a PNG, which is going to be all the packed textures. And then it's also going to write out like block names. And then this texture file, which is going to be like block names and UVs. So I guess we should start working on that first. And then we can start working on everything else. Cool. And yeah, no problem, Essiewood. Okay, let's see. So go back to texture packer. And what I'm going to need for this too is YAML library for C++. So we'll just go here. This is YAML CPP, and let's see how this works. I have no idea which library to choose to, and this is really bright, but I guess GitHub doesn't just let you turn on dark mode. I can't really remember which one. I know, oh, Cherno does use this one. Yeah, this says, I saw Hazel somewhere. Wait, maybe I did, maybe I didn't. I don't know. Okay, maybe I didn't. I know Cherno uses a library like this, and I'm just sort of looking for the same one that he used. I can't remember which one it was, but yeah. We basically just needed to be able to do some basic stuff. And I don't like this one because it doesn't have a single include. Those are usually the easiest to work with. This one has some samples and some tests. A C++ 11, which should be fine. Let's see. Okay, so this is the quick start. Let's see how easy this is to use. So you can just sort of create a buffer. So I guess that's sort of something that he's showing how this works. And then he's showing this stuff. Yeah, I think this API looks pretty nice. I don't know though. I'm just gonna look up the Cherno YAML because I know he used something, and I'd probably want to use the same thing that he used. So, because I'm assuming it's got to be somewhat good, right? Let's see where he put this. I think it's gonna be in vendor for one of these. So, yep. Okay, cool. So he just uses YAML.cpp, YAML-cpp. Can we go back to what it was forked from? No. Okay. So let's go back here. And I'll just stick with this. Okay, so now is the fun part where I have to import this and everything and get it working just so that we can use it. So let's go back to Minecraft clone, and we'll go into here, vendor. And if you can tell, I definitely take a lot of inspiration from the Cherno with the way I set everything up. So we'll just call this YAML-CPP, I guess. I don't know. I'll call it CPP like that just because that's a little bit easier. And I'm going to pull this up real quickly. I have like a bunch of keyboard shortcuts because I always forget all the Git commands. And so this is just easiest for me. Okay, so we want to add a submodule. So we'll do this. And I'll go into here and into here. And then we'll just open up Git. So if you guys have no experience with Git, or if you have a little bit of experience with Git, it's usually pretty simple for the most part. So like I just have these because I always forget what to do with submodules because I don't use them often. But if you want to add a submodule, which is basically like a sub repository, you can just do add, copy the repository name, paste that there. And then I want to give it a file path too. So you can say I want to add it to this specific directory, which in my case is Minecraft/vendor/YAML-CPP. So I would say Minecraft vendor/YAML-CPP. And then what it's going to do, okay, nope. I have to delete that first of all, because it's going to create the directory. I always forget about that part, but there we go. So then I do that, and then it creates the directory, and it clones everything for us. But the good thing about this is if we just do a pull from inside of here, this is an actual Git repository. So we don't have to worry about like manually copying files over and everything every time something changes. The one thing I am going to do, though, is, oh, that says build.bazel. Okay, I thought that said Hazel. But the one thing I am going to do is add in possibly a pre-make file and just sort of include everything myself. What is util? Yeah, I think we should be able to just sort of add everything in ourselves. So if we just include all of that stuff and then compile all that stuff, I think we should be good for the most part. I could just cheat and look at Cherno's because he probably, yeah, he has a pre-make file. So I'm just going to copy his because this is even easier. Still no subscriber mode. Oh, on Twitch itself? Yeah, I don't know if I can enable subscribing until like I hit 50 followers and a couple other things and stuff. So I'm not quite sure how Twitch subscriptions work and all that stuff. Yeah. So we're getting close. I think I have 24 followers. So we're like halfway there, which is pretty good. I'm happy with that. So, and hopefully after this stream, I can like actually release a video and stuff. Donation. I do have a donation link somewhere, but I think I'm still going to wait on that. I really appreciate that though, SE Woods. So, if you can find it, I guess, no, I don't know. I don't even know where it is and stuff because it's like a PayPal thing and everything. So it's kind of like hidden somewhere. Okay. And hopefully you can get another free sub. Okay. So we've got this, and then I'm just going to add in a, not a new folder, but a new text document inside of here. And we'll call this premake5.lua. Change that name, and then I'm just going to drag this into here and paste Cherno's, and then we'll change this up as needed. So static library is fine. Yeah, I guess I'll keep it that name. Where am I putting everything is a good thing to know, though. Here, let's check out what I have for GLM. It's probably a good idea. I've got nothing for GLM. Okay, I think I'm adding all of these manually, actually. If I go to my main pre-make file. Yeah, I'm just adding everything manually. Okay. Which isn't bad. I mean, it just means it's a bigger build, but it's not going to rebuild those files every time. So yeah, I don't think this is too bad. I'll just do this too. Okay, cool. So we've got this thing. We just need to add the correct files, which is, I guess, just source and include. And then we just need to add the include directory. So we'll go into the main file, our main pre-make, add that. And we just need to add in Minecraft slash vendor slash YAML CPP slash, not sure where to go from there. So Minecraft vendor YAML CPP. And then we've got source. Okay, so that's all right. Source. And then we've got include. Okay, so that's correct too. And I think that should be it. And then we just need to add the include directory as well. So I'll just say Minecraft vendor slash YAML CPP slash include. Which if he set it up good, which I think he did. Yeah, cool. Then we get like an additional YAML CPP, which is nice. Okay, cool. So if I just go back into here, and I'm actually going to delete that. So go back into here first, close that out, and delete that pre-make file because we're not going to use it. And we can just go into here and say build 2019. And we can reload this and we should have YAML now. So if I go back into, we'll do a test file. So we'll go into here, source, utils, and then I'll just have like, this is our YAML extended.h, or that CPP. So we'll do that, say yes to that, and then go into here. And this will be YAML extended.h. Cool. And we'll just write some tests in here to make sure that this is all working correctly. I'm going to zoom this in a little bit too, because I just realized I have that zoomed way out. Okay, so I'm just going to change this pragma once to an if not defined Minecraft YAML CPP, or I guess YAML h. Then we're just going to do hash define that, and then end if. Okay, cool. And then we're just going to call this YAML extended. That's good. And then we're just going to add in a function test write, just to see if this is all working correctly. So then I'll go into here, copy that, paste that, remove that and that. And then we'll say include utils slash YAML. There we go. And we'll implement this real quickly. And I guess I'll go into core.h, wherever that went. Core.h. Okay, and then we'll just add in YAML right here. So this will be YAML-CPP slash. And which of these things should I include? That's probably a good idea. I guess I'm just going to do YAML.h and hope that works. So if we go back into this one and we say hash include core, we should have that. And is it when I start working the most fun part? I'm glad you guys feel that way. Sometimes I feel like it's kind of boring watching me. So thanks, BlazeX. I'm glad to hear that. Cool. So we have YAML extended, and then I want to see if this all works correctly. So how does he say to use this? Man, I really hate the light mode on GitHub. They have a dark mode, but it's not on it for some reason, which is kind of annoying. Okay, so it's a YAML parser. See the tutorial. That's a good idea. Okay, so a typical example would be something like this. Let's copy that and see if it works. So we say YAML node config equals load file. I don't want to load a file. I want to write a file first and see how this works. So, okay, yeah, so he writes a file right here. Yeah, I don't get why they have the sign-in required for dark mode. It's like, just let people use dark mode, you know? Okay, so, and it's funny you said that too, because their example is about a login. But anyways, let's see. Let's do basic parsing, because that's what I want to do. Yeah. So this is loading in from a string. I want to load in from a file, though. Do they just have a simple file loading? No, they don't. Which I guess should be expected, because I can load a file myself. It's just not fun. Okay, so. Wait, yeah, this is, okay, wait, no, this is loading a file. I want to see how to write a file. I got confused there. Okay, so this is all just loading in files. Loading in files. What about writing files? Building nodes. Okay, this is what I want to do. Yeah, okay, cool. So we'll do that. because I really don't care about how to write YAML. I assume the library will sort of figure everything out for me. Yep. So this starts out as null. And then as we put it, okay, so then as we add the first value in, it's now a map node. And then we can add in a sequence, which I guess is like a collection of values. This creates an alias. Cool. I don't know what an alias is. And strange loops. Okay, cool. So let's see what happens if we say write. Does he have a write? Dot to string. Let's see. Does he have an example of that? So he's still loading here, still loading. Does he not have an example of how to write a file? I feel like that would be a pretty basic thing to do too. Maybe it was up here. Yeah, okay, right here. Okay, cool. So he writes config YAML and then, okay, and then he just pipes that through. Okay, cool. So if I were to just do this and then pipe out node, we should get something written. So if I just go back into main, let's bring this over here and I'm going to close out core. Let's just try and write a file real quickly and then we'll go from there. So I'll say hash include utils slash YAML, and we'll say YAML extended test write, which should write out a config.yaml file. So yeah, I saw the words already, BlazeX. But let's see if this works out. Okay, so it looks like it's recompiling, probably just compiling the new library. But once it compiles it, it should cache all that stuff, and we shouldn't have to worry about that recompiling again. Okay, it looks like it's recompiling everything. Oh, it's because I changed core, so it had to recompile everything. Okay, cool. So that worked out good. And if we go back into binaries, that's not right. I got to fix that, first of all. We don't have a file. Did it write it somewhere else? So you got test.png here. And it doesn't look like we have a file anywhere. Did I not write it? Maybe I didn't write it out. Let's see. Yeah, I'm going to fix that first of all, though, because that's kind of annoying. So I'm just going to go back into premake. This should be /% prj.name. Okay. So I'm going to rebuild this real quickly. That's cool. Just delete those. Oh, so this is going to trigger a full rebuild too. So yeah. Shouldn't take too long though. We don't have too many files, just a couple of big libraries and stuff. Yep, so we're almost there. Getting pretty close. This is why, like, I was experimenting earlier with DLLs and stuff. If you guys don't know about this website, they have some awesome blogs. It just makes you feel like a terrible programmer if you read it because of how insane these guys are. So this is like a game engine that these, I think it's like 4 dudes are working on. Not sure who they are and stuff, but it's really cool. And if you go to the community blog, they have a lot of blogs just about different things that they have done. And the whole concept of this is they're writing most of the headers in C99, so it's super verbose. And they're also making everything a DLL and hot reloadable. So compile times are really fast and everything. But it's a very cool project. You guys should check it out if you get a chance. Let's see if we got a file. Okay, so if we go to bin and we go into here, we did not get a file. Okay, so I said test write, which goes... Oh, is it because... I'm not sure how file out works, but I'm pretty sure this should... Oh, I have to close it probably. Yeah, that's probably what the problem is. Okay, so if we close the file, And then we check inside of there. We should see a file now. No, we still don't see a file. Okay, let me take a look at the documentation for OF stream. OF stream CPP write file. Okay, so my file, open, pipe, close. That should be all you need to do. This is doing the opening, I assume, and then we close it. So should be fine, I think. Oh, we're not even getting into there. So that would explain why this isn't working. Why is that not happening? So we say memory init. Oh, it's because I play the game there. Whoops. Okay, there we go. Now if we do it, this should work. Okay, so we should hit that breakpoint. Yep, okay, cool. And then we can see what that wrote just to be sure. Nope. Still didn't write anything. That's weird. Did it go into... Okay, it went into here. Okay, cool. So that finally worked. Now we can go into here. And I guess this is the way it writes stuff out. So I'm not very familiar with YAML, but this looks really weird. So I might have to look at the documentation a little bit more or just look at the YAML format. So key should go to value. Key goes to value, so that's good. A sequence should push back first element, second element. So, okay, we get sequence and it passes back that. Yeah, okay. All coding stuff is weird for you, Brother. Yeah. Sometimes it's all weird for me too, so I totally understand that. Let's see what the YAML file format is. Because that just doesn't look right to me, but maybe it is. Yeah, okay, this is what it should look like, right? That's what I assume. Unless he's doing something really weird. Am I planning on joining SOME1? What's SOME1? I'm not sure what that is. Yeah, something's going wrong with the writing of this file too, so gotta figure out that. But let's see. If it can read back in that file, I think that's probably a good thing. Let's write out just a normal file and maybe that'll work. So I'll go into here and I'll just say like that's fine, and then I'll remove this stuff because it sounds like that's weird. Okay. And then we'll run this and see if that works. I do watch 3 Blue 1 Brown every now and then, so I haven't seen the event he released though. I might check that out. Okay, this looks more normal now. Well, that's good. But yeah, 3 Blue 1 Brown is really good, so. Okay, so this just pushes back. Okay, cool. So this all looks good. I think should be good now. We're going to write a few helper functions. So it looks like we have this node, and this node sort of contains everything. So we're going to say include core here. And then we're going to say write vec2. And this will take in a vec2 and the node. And we basically just want to create a bunch of helper functions that we can write this stuff out. Right now, what do we need? We just need a few different things, which is inside of chunk.h, wherever that went. Let's get rid of input and default GLSL and camera and error codes. I don't need any of that stuff. Okay, cool. So chunk h, we basically just want to write out texture format right now, which is just a bunch of vec2s, which are indexed by a name. And I guess we don't really need the ID because the ID doesn't make much sense. So just a name. Okay, cool. So this is what we want to write out, something that looks like this. So let's figure that out. And it's an event he released a video on. You just make a video explaining a math topic or a computer science topic or physics. Summer of Math Exposition 1 is the full form. That sounds pretty cool. Maybe I will do that. Just sort of release a random video on like some sort of data structure or algorithm or whatever. Or like some more advanced computer science topic. I don't know. If you guys have any suggestions to something you'd want to see, let me know. And if I know it, I'll try and release a video on it. So, but let's see. Okay, so we got this right vec2. Quantum computer. That's something I know absolutely nothing about. So I definitely won't be releasing anything on that. Let's see. So node. Oh, and we also need a name for this stuff too. Do we? This is just a vec2. So I don't think, well, we'll do a const char star name, which will just be nice. So let's say node name equals, this might be a string too. Nope, const char, cool. And then we'll do the grandfather paradox. You have to enlighten me about what the grandfather paradox is. I might have heard of it and just, oh, wait, I think you're talking about the time thing. And then Grant Sanderson's tip number 2, be niche. Who's Grant Sanderson? Is that 3 Blue 1 Brown? I don't know if I know his name. But anyways, this is going to go ahead and just say pushback vec2.x and pushback vec2.y. Cool. So that's good. Oh, and that is his name. Okay, cool. Yeah, I'm not sure what kind of very niche subjects I could do on. Yeah. Because there's a lot of different topics in computer science and stuff. Some things that I'm pretty interested in are like parsing and that type of stuff. But you can go in a lot of different places with that. So I don't know. It's tough. I'll look into a few different topics and everything, and we'll see what happens. Yeah. Yeah, so that there's less competition. Yeah. Is there like a hashtag you put with the video or something so that he sees the videos? Because I assume he'll probably be watching a lot of videos. We're also going to want to make a space game. Well, we're making Minecraft, so I can't make a space game too. But we're also going to have a read vec2. This will actually just return a vec2. Read vec2. And this will just take in a YAML node and const char star name. And this will take in char star name. Cool. So that should be good. Don't really know how to submit it yet. Yeah, I'll check out the video and see if that's good. And you'll make sure, okay, thanks, Essie Woods. It can also be Blogspot or something. Okay, that's cool too. And make a space exploration game like Sebastian Lee's. Sebastian Lee's space exploration game is pretty epic. I don't know if I can match that, so we'll have to wait on that. But let's go ahead and let's get the reading working too. So this should just say node name dot get or something like that. Let's see, how do sequences work? Okay, so this is building nodes. Sequences turn into maps. Okay, still a sequence. Okay, so it looks like we can just access them through index. So what we can do is we can say return node name 0, node name 1, which should turn it back into a vec2. So let's do the ultimate test and see if this all works. So I'm going to go ahead and write out, we'll say write vec2. And I guess we should put something just so that this doesn't break. File equals, and I guess I'll just call this like, this is the texture format. Yeah, okay, cool. And then we'll just do write vec2. We'll call this UV. And we'll call this name and then vec2, which I'll just say glm vec2 1.2, 2.3, or 4. And then we'll give it the node. So that should write a vec2 to the actual node, which basically just puts it inside the node. And then we can have something that says void write file and takes in a node. So that will just look like what we had before, which is just a outstream config, or actually we'll just call this texture format.yaml. And this is a std OF stream, and then we can put outstream node, and then we can say outstream.close. And I guess we should take in the name and not what I came up with. Okay, cool. So then if we go ahead, we write the vec2, then we say write file, which is going to be texture format.yaml, and we're going to give it the node. Cool. So that should write the file, and then we want to read the file into a new node and just make sure this works properly. So then we'll just say read file. Actually, we could just say node2 equals read file. This will take in texture format.yaml, and it will return a node. And then we should be able to get a vec2 by saying not that. So new, or we could just call this vector equals read vec2. And this is going to be UV, and then we're going to read it from node 2. Okay, and then if we finally log this, we should get the correct thing. So we can say vec2 and just print this stuff out. And this is going to be vector.x and vector.y. Okay, cool. And you guys have written a bunch of stuff. Okay. So apparently blog post, and Danny will love it if I implement milk first in Minecraft. I don't watch Danny that much. I liked him way back when, and then he started going crazy, and I just sort of stopped watching him. But yeah. And you don't know, Emogi says, I don't know if this is good for the event, but it would be really helpful if I made a basic math for game engines video, like vector math. I've been thinking about doing a video like that too. Just because I've had a lot of people ask me questions about like what math you should know to write games. But I guess game engines would probably be a good one too. And I wanted to do it where it's like sort of like I show you the math and then I experiment with it in Unity so that you can see how the math applies and stuff. So that might be a cool video idea. And fingers crossed, will it work first try? It will, because my code always works first try. Not really. That's just a joke. But anyways, we'll create this read file function too. So this is going to be void read file. File name and write file. I guess that should be file name. Cool. And then we're just going to change that to file name so we're consistent. Nope, not like that. And read file should be pretty simple. This is just going to return a YAML node. And we want this to return a YAML node. Okay, and we go back into here. Let's go back to his documentation. If this does work first try, it's just because I'm using his documentation. So he's basically doing all the hard work for me. I think he had it somewhere in here. YAML load. Yeah, and I think he has load file. Cool. So we can just say return YAML load file name. Okay. So ultimate test should now work if this is correct. So we'll just write in ultimate test. Let's see if this works. Cool. Nope, we got build errors. Well, hey, that doesn't mean it doesn't work though. So this is saying static cast. Okay, see, this is an example of a horrible Visual Studio error because it's coming from a header file, or what's it called? HPP. So like template. I couldn't think of the word. But anyways, you just click on the output tab and it actually tells you what's happening. So it's highlighting this. This is coming from cannot convert from A to T from this thing. No, that's just a warning. Okay, so this is coming from YAML extended CPP line 42. Let's see. And then that's line 39, but which line of my code is doing this would be the nice thing to know. Let's see, world.cpp. Nope, that should be fine. Okay. Yeah, CPP errors stink. And linear algebra and trigonometry is pretty good. There's a couple other things you need to, like vector math I think is super important to know. And like quaternions are pretty easy to understand, but all the tutorials I've seen on them are they're like not good at all. So there's a couple I found that were pretty good and helped me out, but yeah. Okay, I have a feeling this is coming from, so that error did not help me at all, but I have a feeling it's coming from this, because if you look at this, or not that, but this one. If you look at this takes an stood string. And if you pass in a const char star, you might have problems with that. So let's compile that, see if this works. I don't think it did. No. Okay, so it's still not working, so I'm going to say it's not this. And let's see, what else could it be? So that write file should be fine, because I'm taking that in. Let's just comment this out. Let's see what happens if I do that. Narrow it down. Nope. Okay. Vector math is linear algebra. I don't know. I felt like when I was learning linear algebra, that was mostly matrices and stuff and learning about matrix math. And then calculus 3 was pretty much vectors, like dot products, that type of stuff, and everything is sort of when I learned that stuff. So yeah. But I took a weird path in high school and everything too. Or not high school, in college. I did calc 1, 2, 3, and then differential equations. Then I did linear algebra after all that. So that was kind of weird. But yeah. And we learned about all sorts of stuff in linear algebra too. It was like, you know, the identity matrix and then like eigenvalues and all that stuff that I have no idea how any of it works. But yeah, that was fun. Okay, so what's going wrong here? We have write vec2. We're converting here, so that should be fine. And yeah, 3 blue, 1 brown is great. So definitely check them out if you need some help with that. Let's try this. Let's see if it just doesn't like that. I don't think that would be a problem. Yeah, I didn't think that would be a problem. Okay. So what is the problem? That is the question. Is it because of this thing? Let's see. Dot as. Okay, I have a feeling it's because of this thing. Let's see if we can figure out how to convert things. So, okay, yeah, so we do as whatever. Maybe that's what's wrong. So we say as float dot as float. Okay, then if we run this again, now it works. Okay. You know, C++ errors, they suck. They really do suck, because that should have been just clearly obvious that, hey, you have a problem right here, but it did not tell me that. Anyways, I didn't even notice if that worked or not. So, vector 1.2, 2.4. That worked out. Sweet, cool. So we have that part working. We just need to get a little bit better. Yeah, first try. But you haven't been taught vectors yet, but it was a super fun series to follow. I believe it. 3 blue, 1 brown is really good at explaining things visually. So sometimes he goes into a bit too much depth for me, because I'm like, I'd rather just learn sort of the surface and not go that far. But it's very good series, or a very good YouTube channel in general. We need like a way to write out a little bit bigger objects and stuff, because right now we can write stuff. Let's do this. We'll say void begin object name, and we'll take in a node, and then we'll say void pop object. Well, actually, we don't even need to do that. This will just sort of decrease our level of indentation or whatever. Yes, I think this should be good. Okay, I'm just thinking of how this will work internally. So that basically we can indent, 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 and then we can go back out so that we can sort of write objects out pretty easily. I wonder if he has an easy way to do this. I'm guessing he doesn't because of the way all this works. Actually, no, I'm being stupid here. So the way that we can do this, all this stuff, writing out objects, is basically just by creating specific nodes and then writing those nodes to other nodes. So we can have like a write node, which just takes in a YAML. I guess it would, yeah, YAML node, node to write, and then this is the node to write to, and this is gonna be const because we're not gonna change that one. So then if we go back into here, I don't know, I feel like this is getting a little too verbose. There's just no reason to do that. I'm gonna leave it here. This is something I've been having problems with lately, is like something called analysis paralysis, where there's so many different ways to do things. I can't just find one way and stick to it. So I'm gonna stick with this because it's simple. But S.E. Woods says, I've had lots of math taking engineering degree, but never used most of it before now. I got to get some great refreshment videos with vectors. Okay, yeah, I think that'd be fun to do because I do enjoy most of math. Like my degree was part computer science, and then it was, I think I minored in math, so it was pretty good. But yeah, what engineering did you major in too? Let's see. Oh, I had some good refreshment videos. Oh, okay, cool. Well, that's good to know too. But anyways, I'm going to start going back into here, and we want to get our texture packer sort of working to actually write out a YAML file too. Okay, yeah, so that'll be the file path, and then const char star config file path, which will be good too. Yeah, it was part of the physics tutorial, that little vector math thing that I did. So that was pretty fun to do, I thought, because math is just so straightforward compared to programming. Okay, so we've got this pack textures function. Oh wait, no, why am I rewriting this? We don't need to rewrite this. We just need to go up here, and we need to say, oh, this is in the wrong file and everything too. Okay, go back into Minecraft, source, world, and chunk.cpp. No, not chunk. Okay, texture packer. CPP. There we go. Okay, cool. This is what I was looking for. Okay, and then this has a file path, and then const char star config file path. So we get all the images here, and then I want to write them out. And you have a master in construction materials. Dang, that's pretty awesome. I had a lot of friends in like electrical engineering because that was so close to computer science. We had a lot of friends taking classes. And then I had a few other friends doing like mechanical and stuff. So I'm definitely not an engineer. I'm just a programmer. Okay, so we get all the file paths. We're logging out the max width. I don't really care about that. Maybe I do. I don't know. We'll leave that in. So we get all the file paths, and then we basically, as we write them out, we get their X and we get their Y. We don't know what the height of the image is yet, so I probably want to save those. So what we can do is we can have a vector of structures. So I'll just say like struct location, for lack of a better term. That should be good. And then I think these are integers, the X and Y. Yeah, okay. So I have int X, Y. So that should be good. And then we'll just have like inside of here a vector of locations. And this will be our texture locations. Okay, so then we just sort of push all the texture locations into here. And we actually want to also have the name of the file there so that we can reference these without the extension. Okay, cool. So we do that, and as we're writing them, we get the X, we get the Y. So this should be X and Y, and we should have width and height here. Let's see. So we have X, Y, current X, current Y. Okay, so the current X and current Y are the X and Y we want. So save current X and current Y. And you had 0 programming. Oh, thanks. I really appreciate you that my stuff could teach you the programming and stuff. I think you probably had some programming, or at least you had an aptitude for it, because a lot of my stuff isn't really geared to 0 programming people. I don't think so. You definitely did a good job though. Okay, so we saved the current X and Y, and then we want the width and the height too, which we have. And width and height and file name. Which I guess that's just stating the obvious, but you know. Okay, so width and height. There we go. And then we can say push back to our texture locations. Dot push back. And then I'll just do this. See, and C99, you can do like dot and then reference things with a dot notation. So you could say like dot X equals whatever, which is really nice. But for some reason, C++ doesn't have that. I don't get why C++ doesn't have that. Anyways, that's just an aside. Okay, so then we can do current X, current Y. We need the width and the height, which I believe is just right here. Yep, so height, width, height. So that should be good. And then we need the name, which is going to be, we have the image, we have the file path, extension, string, C string. Okay, cool. So, wait, nope, that's the extension. Okay, so if we do image here, dot file name, nope, not replace file name, dot name, nope. They have file extension, right? Okay, wait. What am I missing here? This is image.path. Okay. So image.path.file name. And we'll do it like that for now. Okay, cool. So that should push back current X, current Y, width and height, and the file name, which should be good. What's this saying? I think this needs to be a string. There we go. Okay, that's better. Cool. So we should get all the texture locations. That should map everything correctly. And then at the end of it, we have the output width and the output height. So we can rewrite all those. Or actually, I guess we can just write all those out to the YAML file with the appropriate UV coordinates. So then we can say for auto location in texture locations. Cool. So that'll give us a location. I'll just call that location ref. And that's going to be const because we're not really going to change anything. We want to write this out to the file. So first of all, we'll say YAML node. This is going to be our texture format. And then we're going to say texture format. Let's see. What are we going to call this? Blocks. Yep. And this is just going to be nothing for now, right? So we're just going to do that, which I think should initialize like a blocks thing. We'll see what happens. Okay. And then we'll go texture format, blocks. And then we want to do this how. I wrote up something. Yeah. So we basically want it to be like texture. And then we want the name, and then we want the UVs. We could just have the name here, and then we could address them by name. I think that's probably the better idea. So instead of this, we would just say like grass side, and then it would have the UVs. I like that better. Cool. So that's what we'll do. So this is going to say location.name equals And then we basically want to put in the UVs here. So there's going to be 4 UVs. How are we going to do this? Let's do the UVs first, and then we'll just do that part afterwards. So we'll say texture format, or actually we'll just say YAML node UVs equals UVs, and then we'll do UVs 0 equals, and then this is going to be location.x over PNG output width, and we're going to convert those to floats, and then location.y over PNG output height. Okay, I have no idea how this is going to write the file. I just sort of want to see what happens. Okay, so this is saying we can't do that correctly. Okay, so what should we do? We should call this UVs 0, and we'll say dot push back that, or actually wait, I have a function for this, don't I? Okay, so we could say, this is kind of going all over the place because I have no idea how this API works and stuff. We're just sort of working with this. Okay, so UVs 0, and we want to write something to that. So we'll say YAML extended, which we don't have. So let me include that real quickly. So that is in utils / YAML extended. Okay, cool. We got that YAML extended. And we're going to say write vec2. So the name is going to be 0. The vector2 is going to be location.x over PNG output width, location.y over PNG output height, and we're going to be writing to that node. Okay, so let's see if this actually works right. And this is going to be that, and we'll just say vec2, and I'm going to move all this stuff out just so that that's clear what's happening. Oh, and I missed a brace there. Okay, cool. Let's convert this to float. Float, and float. Okay, so that should convert it to normalized coordinates, right? We should get, excuse me, we should get like on a range from 0 to 1, which is what we want for UVs. And that should write out the first one, okay? And then we want to write out 4. So we got 1, 2, 3. So this is going to be like our 0, 0, I guess. And then we want our 0, 1, or I guess this is going to be like 0, 0, 0, 0. And then this one's going to be 0, 1. So we got x, and then we're going to do y plus height, y plus location.height. And then we're going to have x, y, so this is going to be like 1, 0. So this is going to be location.x plus location.width. And then that's 0. And then we're going to do location.x plus location.height, and then location.y plus location.height. Okay, this should be width. And I'm going to fix all this stuff up so that it looks a little bit better. So don't worry, I'll refactor this off stream. Okay, so anyways, we've got texture format, and then we want to write these UVs there. So we'll just say that. That should write all the UVs, hopefully. And then what we can do is we can just say YAML extended write file texture format.yaml, and we'll give it texture format. Okay. So with that in place, let's see if this actually works. I don't have very high hopes, but we'll see. So if I go back into world.cpp and right here, I uncomment this, we'll see what happens. So this is get pack all these textures, and we also need to pass it the config file path, which is going to be, I'm just going to call this texture format.yaml. Oh, and I guess I should have used that inside of the function itself. Okay, so go back into texture packer. This should be texture format file, which is up here somewhere, config file path. Okay, cool. Okay, let's run this and see what happens. Okay, no crashes, so that's good. And now it's rating all the files. Okay, cool. So it should have written a big file called textureformat.yaml. And would you look at that? That actually worked. First try. That is one of the rare occasions that we can say it worked first try. Yeah. Cool. So we've got acacia door bottom.png. We probably want to remove the PNG part because I don't care about that. But yeah, so then it just says UVs, and then it gives us the UV 0, which is 0, 0, 1, which is 0, and then 0 point that small number. This is the reason we're generating these automatically, because nobody wants to keep track of all that. So what did I do? I basically generated this file, which is all of the pictures that we want. And then I mapped the pictures to coordinates, and the coordinates are where they are on the file. So if we take a look at this file, this says the acacia door bottom.png is mapped to 0, 0, which is the top left of the picture, and then some very small coordinates. And if we look at the picture, you can see that we have the acacia door bottom in that top left corner. So yeah, so sort of like the old terrain.png. I'm not sure what that is, but if it's like an old Minecraft concept, probably. It's basically just going to automatically create these maps for us so that we don't have to worry about anything. And have I ever thought of what else other editors... Wait, okay. Have I ever thought of what else other than games that a game engine could be used for? I have thought about that. Because like you can use game engines for simulations and all that type of stuff, but it's not going to be very good because like game physics engines and stuff, they're not supposed to be accurate. So they'll have a lot of errors, which means if you want like an accurate simulation, it's probably not going to be very good. So you typically have to build something custom for that, which is a shame. So games is probably all it can be good for, unless you don't care about realism, in which case you could create like videos or animations and stuff probably with a game engine. And terrain.png was a picture like this, and yes. Yeah. So Minecraft still does the picture, terrain.png, except they just don't write it out to file. So like that's what I'm going to do in the future too. When you get the loading screen, when Minecraft starts or whenever you switch a resource pack, what it's doing is generating this, except it just never writes it out to a file. And VoxelRiff says, I'm kind of curious now. What do you think of the current community project? The community project is awesome. I think it's turning out really good. I haven't been working on my game engine lately just because I've been like stuck with, I don't know, I've been analyzing it too much and just not working on it. So I think I have to sort of do what you guys are doing and just work on things and not care if I'm using a standard library or something, which is sort of a shift in my mindset that I'm hopefully going to take. But yeah, you guys are doing really good though. Okay, so we have all these maps now, and presumably we can get them into memory. Let's just change it first of all so we don't get the extension. So C++ file path, get file name without extension. So, oh, cool. It's just called stem. That is why we use Google. Okay. So if we go back into here, we can fix that pretty easily just by changing this line to stem. Now, if we rerun this, we should get the correct, or at least what I think is the correct names in there. And that will sort of be our block IDs for in the game and everything too. Or actually, I guess it won't be the block IDs because those will be a little bit different too. But let's just close that and reopen that. Okay, yeah, cool. So now we just get acacia door bottom, acacia door top, acacia leaves. So these are all the texture names. And then they just show exactly where they are mapped to on the actual texture. That is good. Let's see, acacia sapling. Yeah, okay, cool. So that's all good. We write that out to file. Now, how do we use this is the question. Okay, so if we go back into chunk.h, we've got sort of this first part done. Okay, and now we need this block formats.yaml, which is basically just gonna be a block, side, top, bottom, name. I think this is gonna have to be created manually for now until I find a better solution. So for now, I'm just gonna say, create a new file, and we'll call this block formats.yaml. And we'll probably have this be programmatically generated and stuff in the future. For now, though, I'm just going to manually add a couple things in, and we'll see if we can get it to work. So this is going to look like, okay, let's take a look at the other format file too, just so that we can sort of use that as reference. Okay, so this says blocks and then all that stuff. And we basically just want this to say like block. So the name will be the key. So we'll say like grass block. And then grass block, we go in, I guess that's 2 spaces. Yeah, that's 2 spaces. Okay, so 2 spaces. And then we want to say side, top, and bottom. Which textures are we using? And we want an ID. So ID will be 1. Side will be, I guess we don't use strings, do we? Not sure how YAML works. Okay. And you think I should start small, like water, caves, ores, trees, and then different types? Yeah, I think that's exactly what I'm going to be doing too. And yeah, nothing has been added yet. We're getting there though. We're getting there. Okay, so for the side, we want grass side. Yeah, grass block side. So this is what we want for the side. For the top, we want grass top. Not that one. Let's see, do we have, not that. Is it just grass? That's all that. Oh wait, it was there. Grass block top. Grass block top. Okay, cool. So we want that for the top. And I'm not sure how strings work in YAML. I don't know if they need the actual strings. Yes, and I am just opening the Minecraft texture folder and loading those for now. Okay, so then we got the top, and then the bottom will just be dirt, which we can find, not coarse dirt, but just dirt. Okay, cool. Dirt. Okay, so this should be like how we can define blocks, which will be really cool because then we can just add to this file, and you can add an ID, which will be the number ID, and we'll probably have those in incrementing order, and then you can just add different textures, which means we should be able to add new block types pretty easily. And then if we look back into chunk.h, or chunk.cpp, I guess I should say. Yeah, so what I'm doing is I'm allocating just enough memory for IDs. And right now those IDs aren't even being used, I don't think. Yeah, but then what we're gonna do is instead of this, we can use the UVs from whatever our ID maps to get the correct block type. Okay, so that is the plan. Let's see if we can get that working. So let's see. If we go back into here, we need to get this actually working. So we need a block format, which is just gonna be the side texture, top texture, bottom texture. Let's see if that compiles, because I was having compile errors too with this earlier. So we'll see if this works. That does work. And I'm gonna turn off the texture generation too real quick, because we don't need that right now. So if we just go back into world, turn that off right now, and then go back into, that was chunk.h. Yep. And I guess texture packer should be good now because that's writing everything out correctly. So we can close that out now too. And then we'll go back into here. So that's good. I don't anticipate any problems with this either. So we should be good there. And let's see. That is good as well. Okay. And then this, which we're going to offload these to be internal variables. So yeah, we're going to copy that, go into chunk.cpp, and then I'm just going to have these up here. And how do we want this to work? Well, I think I'm just going to do like, these are manual as well for now. I'm not actually sure how Minecraft does this type of stuff, because I assume you have to do some sort of manual labor to get all this stuff set up, but I'm not completely sure how they would get it working. So anyways, this is going to be like grass to 1. So that's how we add in different IDs. We say grass is 1. Do we even need this though? Wait, no. Okay, this is going to be loaded in from the block formats, right? So we can get that from there. So we can actually do that, make this static, and make all these static, and make this static, which is basically just internal. Okay, yeah. So we get block formats, which we can also get from here. And then we're going to have a vector from a string to a texture format, which is basically just going to be how we go from here to here. Okay, so this is just sort of like if you've done anything with relational databases or whatever, this is basically what we're doing here is we're creating some sort of relationship between blocks and textures. And compiler errors is greater than no compiler errors and expected stuff happening. That is true. Yeah, that is true. I agree. Okay, if we run this, do we get no compiler errors? No, we get a compiler error. Okay, cool. See, but compiler errors like this are just bad all around. So I think this is happening. Let's include vector and unordered map. And I'm going to take those out of here because let's see. Yeah, it doesn't look like I have that. And let's actually change this to a std array, just because that's a little bit better. Actually, I don't know. Okay, I'll leave that as is for now. It doesn't really matter too much to me. Okay, anyways, that's fine. That's fine. We should be good here. Value type is not a member of Minecraft texture format. Yeah, like I have no idea what this is saying. Okay, well, okay, let's see. So if we go back into here, block format is just a bunch of strings. That should be no problem. That's just a glmvec2. That should be no problem. That should be no problem. We have the structure right here. I have a feeling it's the map, but I don't know. Oh, I think that's our problem. That should be a map, not a vector. Yeah. Yeah, CPP is whack with errors. I mean, they could have just told me that that was wrong, but instead they gave me all that garbage that told me absolutely nothing. So, yeah. Okay, anyways, so we've got our block map. We're also going to need to do like a, let's not do a load block, but just a void load blocks. And this should load everything into memory. And then we'll just do like a const char star. This is going to be our texture format config. And we'll do a const char star, and this will be our block format config. Okay, cool. And then using these two, we should be able to load everything into memory into those maps that we had. So if I copy that, go all the way down here. We have our format config and all that stuff. That's good. That's good. Then we'll say YAML node texture config equals YAML extended, which I need to include. So we'll do include utils / YAML extended. And we go back down here. Read file texture format config. So that should load everything into memory there. Then we can say block format. We'll just call this texture format actually. Equals YAML extended read file block format config. Okay, then we want to loop through all of the blocks in here. We want to say loop through block in block format, which Yeah, I'm assuming he has. This is a YAML iterator value type. Okay, so I'm assuming we can go like block, blah, 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 get our stuff, okay? So if we look into here, what we want to do is we want to get the ID first of all. So we can say int ID equals block ID, which should give us that. But yeah, this is going to say, okay, we need to say as int. Okay, there we go. Then we need to get, yeah, I'm going to remove this now because we don't really care about that. This is the actual stuff. Okay, so we want to get the side, top, and the bottom. So we can say stood string side equals block side dot as stood string. Not sure if that's going to work, but I assume it will. Top equals block top dot as stood string. And then just get the bottom as well. And that should be good. I'm going to compile this real quickly because I have a feeling since we're using so much template stuff, we will probably run into an error somewhere. Nope. Okay, cool. So that's good too. So we loop through all the blocks. We get each block side. And actually, I just thought of something too. That might be because we're not actually calling the function, so it's not compiling. So let's go ahead and we'll just write include chunk or world chunk.h. And then we'll say block, what do we call that? Block map. Okay. Block map, load blocks. There we go. And then we want to give it our files, texture format config. So texture format.yaml and block format. So block formats.yaml. Okay, cool. So if we run this one more time, we should get no errors. Okay, yeah, see, now we get an error because of templates. No, okay, this is just because it's an unresolved symbol. So we include chunk. Yeah, when I think it's going to throw an error. Okay, so we include chunk. We've got this block map. Then we've got this void load blocks. Did I just mess up a name? No, that looks right. Yeah, that looks right. Copy that. That is right. There's no way that could be wrong. Why is it saying it's not implemented? Oh, because I have to put this in a different namespace. Okay, that makes sense. Which we don't even have a namespace here. So we'll say block map. Okay, cool. I guess technically this should be in a different file altogether because it just doesn't make much sense. I'll refactor this after the stream and get all that sorted out. Okay, anyways. Let's run that one more time, see if we get an error. We do. So that is coming from right here. It doesn't like this. That's good to know as well. Why does it not like this? Is it because of... No? Yeah. Oh, it's because I formatted that incorrectly? Wait, I don't know. I got to rewrite that file now too because I lost that somehow. Let's see. Okay. So if we go back into world, let's redo that. I think I have to comment out that line too. Yeah. Let's comment this line out. I guess that should be in world anyways, but yeah, let's comment that out. Let's see what happens. So it's going to generate that file again so we can see. Okay, so the way it does all this, I believe we should be good. This looks like this is a list. Yeah, so if we just have named stuff, it should just go through there perfectly fine. I don't know if it's because... Yeah, I think it's because strings in this thing don't actually have strings. But still, that doesn't make sense why it didn't like that. Grass block. So then if we go back to here. So we go through each block in block format. Let's comment this out real quickly too, because that had problems. And then go back into main. Unload that. Go back into chunk or world. And comment that back out. Okay, let's run this again. and see what happens. Yep, we get the same problem. Why is it not liking this? Let's go look at his documentation and see what he says. If we want to iterate through all the keys. Okay, so basic parsing for primes.size, const iterator, primes.begin, primes.end. Okay, so that should be fine. This is just for iterating through a list, though, which we want to do this thing. Okay, yeah. So this should be first as string. Okay, so, okay. I think I see what the problem is. So we should be doing this is block dot second as int. This should be second. Wait, no. That's not going to work. This should be first and then ID. Okay, I think that's what we should have. Or I guess second. And then this should be side. Okay, I think that's how it should be. So let's change that. And that, let's see what happens now. Okay, cool. That worked. I'm not sure if it actually worked. Let's see. We'll say logger info percent %d ID ID. And we should get 1, and then we'll just do the side to side side.cstring. Okay, cool. So if we do that, we should see the correct stuff. We get ID is 1, side is grass block side. Awesome. That is working. Okay, cool. So we're getting there. Almost there. So we want to load this in again, and hopefully it doesn't ruin it again for whatever reason. That's in chunk.cpp. Okay. So we go through. We've got the side, the top, and the bottom now, and we want to populate name to ID map, block formats, and texture format. Okay, so copy that just so that I have a reference. Comment that out. Okay, cool. So name to ID map. How do we get that? Well, we just say name to ID map. That's a string to an int. What is the block's name? It's going to be block.first.as stood string equals, and then we want to give it that ID. Okay, so that's good. Block format. Yep, I don't think the block format really matters too much, does it? Let me think about this. Yeah, the block format does matter, and we need to make sure that this all gets inserted correctly. So that's probably a good thing. For now, though, we can just say block formats dot push back, and I guess I could do in place back. I really don't care. What does a format look like? Just side, top, and bottom texture. Okay, we have the side, top, and bottom texture. So we could just do side, top, bottom. Okay, so now we got block formats done, and then texture format map dot push. Oh no, we've got the texture format map done, right? No, wrong. So we need that to link to a texture format. We have the texture format right here. Okay, to get to it, we need to go blocks, and then we need to go whatever side we're on. So, and what is this? What does texture format look like? It just looks like 4 UVs. Okay, and we've got 4 UVs in there. Okay, so we can go ahead and say texture format dot second, or actually no, we don't have anything for texture format. Okay, we need to get the block's name, which is block.first.as stood string. That's the block's name. No, that's not what we want. We want the side. Okay, so texture format side, which should get us the side's name. So that should go grass block side, find grass block side. So then we're here, and then we need to get UVs. So then we can say UVs, and that should get us the YAML node ref. We'll make that a const ref. That's the UVs, 0. Okay, and then that should just be, oh, and then we actually need to do 0, 1, 2, 3. Okay, so UVs, and then I'll say 0. Duplicate that 4 times. 1, 2, 3. 1, 2, 3. Okay, so now we have all the UVs, and now we just want to load those into our texture format, which is a string to a texture format. Okay, so how do we get the texture format? Well, we can just say that. Block format. Well, actually, okay, we'll just call that format. Okay, and then format dot UVs 0 equals UV0. We need the 0th thing as a float. And I guess this is where we could use, yeah, here. We could use our file reader thingy. So YAML extended, read vec2. Name is going to be 0. Node is going to be UVs. Okay, this is where it's going to be a little bit easier. So remove that. This is just UVs. So we read that. Why does this not like that? We can't bind. Oh, we're reading, so that should be const. Okay, let's go back into YAML extended. Whenever we read, this can safely be const and const. Okay, cool. So we read that, and we get a vec2, UV0. Then we duplicate that a few times, 1, 2, 3. Then we can say format, move this down, equals UV0, 1, 2, 3. And this is also going to have a brace initializer. Okay, cool. So that should basically fill this with the correct UVs. And then we can finally say, get the map from the string to the texture format from our block's name, sort of like this. We'll go block first as string, except this is going to be texture format map to our format. Okay, finally. So what we should end up with is we basically get everything loaded into memory. And we should be able to use these maps now appropriately. So if we're actually inside of our loop generating our chunk data, we need to get the ID first of all. So, oh, I guess this should be the other way around, shouldn't it? This should be int. I don't know. We'll think about that. I might need, yeah, I think this should be int to a stud string. ID to name. Okay, and then we can go back down here and just fix this up. ID to name, ID equals that. Okay, there we go. That should be better. This should be ID to name map. Fix that. Okay, cool. So now we should be good. That should get us all the IDs. And then in here, we can say stud const stud string ref name equals ID to name map. And we basically want to get this array expansion up here. And we can say array expansion. Actually, no, that's wrong. We can say chunk data array expansion. Okay. So that should give us an integer. which is a number, which is an ID, and then that should map it to the appropriate name if this is all working appropriately. So once we have the name and the ID, we can get the block format and we can get the texture format map. We might not even need this block format thing because of this. I'm not sure. I'll have to rethink the relationships and stuff a little bit more. But for now, we'll just get the texture format map. So we can say const texture format and texture format equals texture format map, and we'll just use the name. Okay. Yeah, cool. So that should give us the UVs. So now we've got the position, offset. That was some debugging. We have the elements. Then we finally have the UVs. And instead of using this, we'll say texture format dot UVs 0. And so on and so forth. I should probably also see, whoops. What was I? Okay, so this is 10110100. So this is the order it should go in. So I need to modify our texture packer very quickly to make sure it's doing it in the same order, because I don't think it is right now. Yeah. So right now it's doing, this is going to be 0, 0. So let's see here. We should have 1, 0 as the first thing. Okay, so that's going to be this one. So this should be 1, 0. Okay, then we have 1, 1, which should be this one. So this should be 1. Then we have 0, 1, which should be this one, which leaves this one. Okay. I'll reorganize all that and everything in the future. But yeah, so that's good now. And then we can just say this is texture format.uvs 0. And then I'll copy that, paste it over that, and we can just do 1, 2, 3. Okay, with all of that in place, and with any luck, this should work. I'm going to have to do one last thing, which is say for int I equals 0 until I is less than chunk width times chunk height times chunk depth I plus plus. And SE Woods, I am a programmer for a living. So I specifically work at a company called Alliance Bernstein. It's like a, what's it called? Like a wealth management company. So I work on helping design systems for like all the stock traders and the researchers and stuff so that they can successfully research stocks and do their day job easily. So it's just a bunch of internal tools. I think right now I'm working with like C#. And we're converting some old legacy C++ code to C#. So it's fun and I enjoy it. And it's got a really nice office. So that's also cool. And it's in Nashville too. So I'm okay giving that out because I don't actually live in Nashville. I just live close to Nashville. So, okay. So anyways, we're going to go through all the chunk data and then we're going to say chunk data I equals 1. So we're going to set everything to a grass block, hopefully. Let's see what happens. It is pretty good, yeah. It's fun. Okay, so we get an error. That is expected because of this. That is also expected because... No, that is not expected. Okay, wait, let's go back into this and see what's happening. Okay, so we go here. It doesn't like 0 as a name for this. What is this? This is... UVs, P node, it says its size is 1. That's true. Wait, no, that is not true. That shouldn't be true at least. Let's see. Okay. So the memory, this is the node. I have no idea how this works, but we're just sort of inspecting it to see if it is what I think it is. 0 dependencies, I guess that kind of makes sense. Okay, the data is, oh man, I have no idea how this guy is mapping this stuff out, but I don't think this is doing what I think it's doing. So what I think this should be doing is getting me texture format side UVs. Oh, okay. I think I know it's just I have to add in blocks. Okay. Because I think if we go to the very top of this, yeah. Okay, I think that should fix that. Hopefully. Okay, let's try this again. See what happens. Cool. Now we get, holy crap, it did something. We're just getting a green cube. Yeah, that's not right, but hey, it's better than nothing, right? Let's see if we're getting all the correct UVs and stuff. So let's do this. Let's see if we get the correct top and the correct bottom. And then let's also do this. Let's see. And then we'll say logger info UV 0, and we'll do 2.3F. And just make sure that this is working okay. We'll say uv0.x.y, and we'll paste. 1, 2, 3, and this will be 1, 2. Oh no, 1, 2, 2, and 3, 3. Okay, cool. So let's see if we're getting the correct information there. So close that out. So we get grass block side. Oh, top shouldn't be grass block side. Bottom shouldn't be grass block side. And we're getting the same thing for all those too. That's weird. Am I doing this right? It's giving us grass block side for everything. It got the correct ID though. Oh wait, did I just have a typo? Side, top, bottom? Nope, side, top, bottom. Oh, that would help. Let's change that. Okay, let's try this again to see if this works. Let that run. Okay, so we get side, top, dirt. That's correct. It looks like these are all the same, which is why we would just get that green blob, because it's not actually pulling the correct UV coordinates. So let's see what's going on here. Oh, that would help. Make sure you guys change values when you duplicate lines. Otherwise, it's not going to be the right thing. Cool. So that's different. It's still not right. It's really cool, though. We get a weird... Should this be a new block in our Minecraft clone? The green-white chunk. I don't know. The null chunk. I don't know. Let's see if this is right, though. So... Oh, it's because we're only doing the side. That would make sense, too. We also need to do this. Okay, I see what's going on now. So we're only putting in the side. We also need to put in the top and the bottom, which we're not doing. So if we were to copy that, we could say this is the top. So UVs equals texture format blocks top UVs. And then this one would be the format map for, let's see, texture formats. So then block formats. How does this thing work? Okay. So we've got block formats and then we've got texture formats. Okay, this is why I separated this. Now I remember. Yeah. So we need block format and texture format for a very specific reason. So texture format map is just going to hold in side UVs. So this should be texture format map side equals format. This should be whatever this one is, the top. Yep. And then I'm going to do that so that we don't get a duplicate definition thing. And then actually we'll leave that, and then we'll just first of all leave that, and then we'll do that and that. Just give it a new scope. Okay, cool. And then we'll do that, and We'll do that, give that a new scope, and then we just need to do the top. Or the bottom, I guess. Okay, so then this is going to be the bottom. And bottom. Okay, cool. So then we get those into the texture format, but then we also need to add in our block format map, which we do, which is right here. So that's good. That way we can map appropriately to the side, top, and bottom. Okay. So then we have an error up here, which is we get the array expansion. And then we're just doing the same thing here. Okay, so we can't just add in all of these. So if I equals 0, actually, wait, where is it? Because I have, okay, so this is the name of the block, right? And then we need string side equals block formats. No, we need texture formats. Actually, I guess we should const block format. Block format equals block formats. And then we want to get the ID from the name. Or no, we have the ID already. The ID is right here. It's this thing. Okay, here. So let's copy that. Const int block ID equals that. Cool. Okay, so we got that. We have the ID. Now we can get the block format just by using the block ID. And then we can get our side by using our block format dot side texture. Okay, and then we need the top and the bottom. And let's get that real quickly. So this is gonna be the top texture, bottom texture. Okay, cool. So we got the side, top, and bottom, and then I just want to change this up very quickly. If I equals 0, which is the top, we're gonna use top. So just change that. Actually, we could just do, what is this? This is a texture format. So const texture format equals top. And then we could just do that. And then we'll do that, and we'll do that. And then we'll say this is I equals 0. If it's 0, we do the top. If I is greater than 0 and I is less than 6, or 5, I guess we should say, we'll do bottom. Otherwise, oh, and I should have the otherwise thing there. We'll do the side. Or no, this should be side. That should be bottom. Side, bottom. Okay, cool. Let's see what happens now. And SE Woods, I just saw all of that, but no, you're fine. I just want to answer it. I just had to finish that very quickly. And I'll have to fix that anyways. But you said, do you know the general process after you finished making a game and the next step is to release it? Do you get an external party to check the code for errors, etc.? And you don't need to answer, oh no, I like the off-topic questions. Those are good because it helps keep the stream interesting. But I haven't released any games really fully. So probably not the best person to ask this, but I've watched a lot of, if you want to watch somebody who's released like actual games and stuff, Jonathan Blow, he created The Witness and another game. I can't remember the name of it. But I think he basically, I don't think he gets an external party. I think he has a few different employees, and so he probably has like specific QA testers. Yeah, I think that's the general process, is you would get people to like alpha test it or beta test it. And yeah, The Witness is a pretty good game. And so if you got a bunch of people playing your game to test it before you actually release it, and you could give them perks like say, hey, you can play the alpha for a cheaper price or whatever. Then you can have them report all the bugs and stuff, and then you can sort of go through and fix those bugs and then move it to release once you're satisfied with how you think it'll turn out. So I think that's the general process that most people go through. There might be other things too, though. Okay, so where are we getting that exception to? So this is side texture is a string, top texture is a string, bottom texture is a string. Let's do that. see where we get the error. Okay, so we get, that's fine. Okay, that's where we're getting an error. Let's go back into there. So the name is grass block. Okay, that's fine. Block ID is 1. Block formats has, oh, we have to, okay. Since I'm using 0 as sort of a null block, I just have to do that. Okay, cool. Maybe that's not the best idea. I'll have to figure that out a little bit later and stuff too. But anyways, okay, cool. So that's working now, but it's still doing the wrong thing. We're getting a different texture on the bottom though. And the top. Oh, I know why that is too. It's because we're using the wrong texture. If I just go back into the world, we are still using this texture. Let's use the texture that we generated, which was test.png. And if we run this again, oh, so close. I was really hoping it would work. Okay, so we got a assertion error. Failed to load image. Okay, so it failed to load the image. The image is fine. Did I just give it the wrong path? I probably gave it the wrong path. Let's close that. Yeah, I gave it the wrong path. This should just be right there. Okay, cool. Let's do this again. Come on, this should work, hopefully. Let's see. Oh, it's so close. We're so very close. The bottom is dirt, but it's just kind of off. And I think I just have the texture coordinates off a little bit or something. But SE Woods, you said, I did not know if f.ex hired paid coders to go through the project. Yeah, I don't think you should hire people to test it. Some game companies, okay, maybe you should. There are two ways you can go about it. Big AAA companies will pay QA testers because then they get testers who are like trying very many different things. But if you're like an indie game developer, I think it's fine if you just release it to alpha or beta and you're like, hey, just play my game. And then if it crashes, you can be like, it's in an unstable state, so it's okay if it crashes. But then you can get people playing it and stuff and then hopefully resolve the biggest bugs before you actually release it. So, yeah. I think that's probably the best way to go about it. Our texture thingy is not working 100% correctly, though. I want to see what's wrong with that. Is it because of this? So this is 0. Let's rate that first. And then 1. Then 2. Then 3. Okay, let's see if this fixes it. Maybe. Actually, that's not going to change anything, I don't think. Yeah. We need to actually write out that now. Yeah, no problem. I like the question. So you guys are perfectly fine to ask any questions you have. Okay. So we are very close. Anyways, I think I'm probably going to leave it off right here for now because I'm tired. But we've basically got it in a state. I will work out the bug offline, which is basically it's just getting the wrong texture coordinates for whatever reason. But we basically got it in a state where we will be able to load in several different blocks pretty quickly. Whoa. It just worked that time. I don't know why it decided to work this time. Okay, well, that's an even better place to leave off the stream. So now it's working. Don't know why, but it's working now. And you can see that we get the side block and we should get the top block, which I can actually just check by going into here. Yeah, we get the top block. It's gray because Minecraft tweaks the color based on your biome. So they leave it as a grayscale so that you can turn it to green. But yeah, so now we can load in different blocks. Since we're here, I may as well just go into here. We'll do sand because I just want to see if this works. So if we do this and then we do ID is 2, side is sand, which now I got to go into here to figure out. Not sandstone. Not sandstone. Red sand. Not that. There we go. Sand. Okay, cool. Yeah. So if we just do sand for all the sides, top is sand and bottom is sand. we should be able to add in new blocks pretty easily just by going into chunk. And right now I'm setting all of this to that. But if we say if I mod, well, we'll say if, yeah, if I mod, no, okay. I'm going to change up this loop to do the same thing here, just so that we have a little bit more control. And then we can go that. And we can say if y equals or is less than 10, chunk data array expansion equals 1, or actually we'll do 2, else chunk data array expansion equals 1. So now we should get sand on the bottom. So this is how easy it will be to add in new blocks and stuff, hopefully. So if this all works correctly. Yes, it worked. Okay, that is a good feeling. Cool. So now we get sand on the bottom and we get we get grass blocks up there, and we should be able to add in any block type we want just by doing that now. That's awesome. And I should definitely post on YouTube when I go live on Twitch. Yes, I think I will start doing that pretty soon because I don't get a lot of viewers, but I did want to get it to like this state so that I have something to show, so that if anyone joins from YouTube, they can sort of, or I can create like a appealing teaser trailer or something. But yeah, I'll be releasing that soon. But basically, we've got chunks and we've got block types. So this is a really good place to be in, because now we should be able to generate multiple chunks and multiple blocks in the next episode. That is it for this stream though. Thank you everyone for coming, and it was good to see you all. So hopefully I'll see you guys next week too. If not, that's fine. I understand. But yeah, good stream. And it was good seeing you all, you guys. And I'll see you next week if you're able to come. All right. Thanks for watching.